I want to start with questions from homeworks. Does anybody have anything from any of the recent stuff we've been doing? Miriam, looks like you're ready to raise your hand.
Well, I don't know. It was like the homework that was due 2 days ago.
Okay.
But like holes in the graph. You just like do one of those.
Sure. Yeah. All right, let's grab one of these. All right, let's say we do 11. How's that look? That look okay to you? All right. So I'm going to start by trying to rewrite my equation in that transformation form. So I'm going to have 1 sine of, I'm going to have to factor off a 2. Hello. Thank you. MJ and Mora, you guys have some passes coming here. You want to come? You can come up and grab them right now. Sure, that's fine. But remember that I have to write that coefficient of 2 as like a 1 over c. So how do I write 2 as 1 over c? I do 1 over a half, right? Or it's kind of like doing the reciprocal twice. So those are my values for A, K, H, and C. Does that feel okay? So the amplitude is the absolute value of A, so that's just going to be 1. The midline is y equals k, so that's y equals 1. The period is 2 pi times the absolute value of c, so that's just going to be pi, because 2 times a half is just 1. And the frequency is always 1 over the period, so that's pi, or 1 over pi. So what I'm going to do now is I'm going to write my transformation map, which is always cx plus h comma ay plus k. And I'm going to do that transformation to the key points for sine. So I'll go to my reference point sheet, and I'll look at the reference points for sine. So 0, 0, pi over 2, 1, pi, or pi 0, 3 pi over 2, negative 1, and 2 pi 0. So that's what I'm going to copy down. Those are the points from my parent function that I'm going to be transforming. So 1/2 times 0 plus pi over 2 is just pi over 2. 1 times 0 plus 1 is 1. 1/2 times pi over 2 is pi over 4, plus pi over 2 is 3 pi over 4. And then 1 times 1 plus 1 is 2. 1/2 times pi is pi over 2, plus pi over 2 is pi. And then 1 times 0 plus 1 is 1. 1/2 times 3 pi over 2 is 3 pi over 4, plus pi over 2 is 5 pi over 4. And then 1 times negative 1 plus 1 is 0. And then 1/2 times 2 pi is pi, plus pi over 2 is 3 pi over 2. And then 1 times 0 plus 1 is 1. So now I'm going to go ahead and plot those points. So pi over 2, 1 would be like there. 3 pi over 4, well, that's going to be halfway between 1 and a half, right? So that would be like there. And then we have pi 1. 5 pi over 4, that's going to be in between 1 and a half. So that would be like there. and then 3 pi over 2, 0, or I'm sorry, 1. So like this is one period of my graph, but I'd like to fill the available space, right? So I'm just going to kind of continue the pattern of point placement as it happens. So I'll go like a half over and 1 up, half over 1 down, half over 1 down, half over back 1 up, and then just kind of repeat that. And we'll do the same thing over here. And that ought to do it. Does that feel okay?
Yeah.
Yep. So when I'm looking at your graphs, if you're drawing your own graphs on your own piece of paper, graphs should have XY axes. Those axes should have scales, like tick marks. Those tick marks should be labeled with how far apart they are. When you draw your graph, you should have points plotted where I can visibly see where the points you plotted are. Okay? A lot of our graphs left a lot to be desired when we drew them by hand. Some of us were fine, right? But many of us just kind of did like, you know, you might have done this and done like that. Well, what's that tell me? It doesn't tell me beans, right? Like there's no points, there's no tick marks, there's no, you know, things aren't labeled. You know, this is for you too. I think you knew this one was coming.
Yeah.
You look confused at the other one. This one you're ready for.
Yeah.
You're welcome. So when we're doing these graphing problems, please be a little bit more deliberate in how you're constructing your picture. The picture is what I care about the most, right? That's the end product. That's what we want to have. All the work associated with is excellent. Like that's going to get you partial credits if you goof something up. But I gotta see the picture at the end, right? Is everybody okay? Does that feel better, Miriam?
Yeah.
Sure. And again, like every single one of them comes down to just like creating that map, pushing the points through the formula that you wrote, and then plotting your new points.
What I was doing was like 2 weeks ago.
Yeah, I remembered somebody did that in their homework. That was you. You used the ones for the x squared, right?
Yeah, I forgot about the whole sign stuff.
That's okay. That happens. That's why we do the homework, right? Hopefully we get those mistakes out of the way before the test or something. Anybody else with questions from homeworks past? Wade?
Can you do anyone like 1 through 8?
The most recent one?
Yeah.
Sure. All right. Stupid thing. Come on. Stop fighting me. All right. So first thing I'm going to do is I'm going to use my eyes just to identify where the midline is. Remember, the midline is going to divide the graph in half. So like half the graph should be above the midline and half should be below. So that midline looks like y equals 1. So it tells me the k value is 1. The amplitude is the distance from the midline to either a maximum or minimum. So that tells me the amplitude is 2 because I've gone from y1 to y3. So because the amplitude is the absolute value of a, I know a has to be positive or negative 3. Then I'm going to look at the period. So the period could be from like minimum to minimum. So I start off at 1/2 pi and I go to 2.5 pi. So the total there was 2 pi that was covered. And since the period is 2 pi absolute value of c, I can see right away that the c value should be 1, and I'm always going to choose the c to be the positive result. Okay, so that's what I'm going to get from the graph right away. For sine, from the parent function, I'm going to choose the point 0, 0. That point is a midline point that's preceded by a minimum and followed by a maximum. From the resultant function, I'm going to pick another midline point. I'm going to pick this one because it was labeled for us, which is pi comma 1. Preceding that midline point is a minimum, and following that midline point is a maximum. So because those are the same kinds of points, they're both minimum, midline, max, tells me the a value is positive. And because the x-coordinate on my resultant function is a pi, that tells me the h should be pi. So my answer should be a times sine 1 over c x minus h plus k. And I'm done. Grace, I had to really fight myself not calling you Victoria there.
What if I chose like another point?
That's fine.
But would I get another answer?
Correct. Your h value would be different. Potentially the sign on your a would be different. Doesn't make it wrong.
And how did you get a is 3?
So since they were the same kind of midline point, I know that I'm going to choose the positive option for a. If they were opposite kinds, if it was max, midline, min, on my resultant function, then I would have picked a negative a. So if I had chosen, say, this point, where before it was a maximum and after it was a minimum, then the a would have needed to be negative.
Because I got a is 2.
Oh, it should have been 2. I just counted wrong. Should have stopped me earlier. There. My apologies. So the k and the c always are going to be the same, regardless of what points you pick to use this. The a will always be positive or negative, the same number, regardless of the point you pick to use it. The h will definitely depend on just the point you picked, though. That could be wildly different, depending on the point you chose. Kate.
When you're doing cosine, do you also pick a point from the middle?
I would pick an extreme point, a min or a max. Yes. Good. Wait, does that feel better?
A little bit, yeah.
Okay. All right. My plan today, so we're going to finish up section 3.1. We've been on this for 3 lessons now, right? So what have we done so far in 3.1? We've taken an equation and used that to generate a graph, right? And we reviewed that process with Miriam's question, correct? And then we've taken a graph and used that to generate an equation. An example of that was Wade's question that we did just a minute ago. Where is that at? Over there. Okay. What we're going to talk about today is going to go from, we're going to be given a description and then be asked to go to an equation. So a graph is a lot of information, right? It's basically the most information we could possibly provide for you. A description, we're going to give you some of the information from a graph, but not all of it. So you're going to have to be a little bit more, we'll have to be a little more clever about how we're using the given information to figure out the values for A, C, H, and K. But it's still boiling down to the same process, really. So we're going to look at a couple of examples here to start. Here it says construct a sinusoid with an amplitude of 4, period of 3 pi, and passes through the point 3, 1. When we say sinusoid, it just means sine or cosine function, right? So you're free to choose which one you want to use. Mr. Kulik, does it matter? In principle, no. But in reality, you can make your life much easier by choosing sine or cosine wisely based on the problem. That's going to be one of my points of emphasis for you, because I don't know about you, but my life's hard enough. I don't need to be making it harder than it has to be. Same idea here. We're going to try to choose whether we want to write a sine function or cosine function intentionally so to make the problem as easy as it can be. Everybody's okay with that plan? So let's talk about how I'm going to choose. It's all going to boil down to the point or points that are given to me. So here, the problem just says the graph needs to pass through this point, right? Doesn't tell me what kind of point it is. That doesn't tell me that it's a midline point. Doesn't tell me that it's a maximum. Doesn't tell me it's a minimum. All it needs to do is pass through that point. So it gives me a lot of freedom. It's I who are going to be able to choose where that point falls on my graph, whether it's at a maximum or a minimum or a midline point. Everybody's okay with that? So we're going to choose that right now for starters. Which one do you think is going to be the easiest one to use? I'm going to choose it to be a midline point. And in fact, the type of midline point I'm going to choose it to be is the one that's preceded by a minimum and followed by a maximum. Since I'm choosing this to be a midline point, what do you suppose I'm going to pick for my parent function? I'm going to pick sine. Since these are the same type of midline point, that tells me that the A value has to be positive. Since the x-coordinate of my reference point is 3, that tells me h has to be 3. And because the y-coordinate of my reference point is 1, it tells me the k has to be 1. Maya. Of course. Whenever I'm given the option to choose what kind of point I want to make, where I want that point to appear on my graph, I'm always going to pick it to be a midline point, because when I do that, I get the h and k for free. They just, boop, they're right there. Is everybody okay with that? What do I still need? I need to figure out the A. I know the sign for A. I know it has to be positive, but I don't know what the number is. And then the C, right? Well, I know that the absolute value of A is just the amplitude, which I know is 4. So that just tells me that the A has to be 4 because I know it has to be positive. Color haven't I used? I haven't used this purple color, right? Everybody's cool there? And I know that 2 pi times the absolute value of C is the period, which I know is 3 pi. So if I divide both sides by 2 pi, my C value is, or absolute value of C is 3 over 2, and we always pick C to be positive. And now we have everything we need, right? We have H, we have K, we have A, and we have C. So I can say Y equals A times sine of 1 over C. But instead of writing this as 1 over 3 over 2, guess how I'm going to write it? Yeah, instead of writing as 1 over 3 over 2, I'm just going to write that as the reciprocal, 2 over 3. And x minus h plus k. So that's an answer. Right? Very similar to what we did in the last homework set. You're just not given a picture to go with it, right? You don't have like infinitely many choices of points that you could use. You're limited to like the information that's given to you. But we're still kind of doing the same thing and using a lot of the same ideas. Let's look at a slightly trickier version of this same problem. So first thing I'm going to do is I'm going to decide whether I want to do this as a cosine or a sine. So I'm going to look at the kind of points I'm given. I'm given minimums and maximums, right? Or I'm given a minimum and a maximum. So what kind of function are we going to use? A cosine, right? We use sine for midline points, and we use cosine for mins and maxes, just like we did when we were doing the graphs, right? When we're doing a cosine graph, we choose an extreme point, a min or a max, from the function to use. When we're doing sine, we chose a midline point from the graph to use. Same rules apply here. Just someone's doing the choosing for us. All right, so let's think about what's going on here. So I have some minimum here at 510. And then I have some maximum here at like 1532. Everybody's okay with that? If I extend this out, then that's now like a full cycle of my graph, right? Everybody can kind of see that. But we don't know where that end of the graph is over here. But we know where it ends right there. What percent of a period does that appear to be in blue? Half, right? Everybody agree? Looks like half to me. So we can say that 1/2 the period is going to be the maximum, or the x-coordinate from the maximum minus the x coordinate from the minimum, and I'm going to do an absolute value of that. So that's going to be 15 minus 5. So that's 10. So if I multiply both sides by 2, I know 1 period is 20 then. Everybody agree? And I know that 1 period is 2 pi absolute value of c. So c is going to be 20 divided by 2 pi, or c is going to be 10 over pi, if I reduce that down. Again, I'm going to choose to make the c always positive there. So far, so good? My midline should be right there, correct? So that equation for the midline should be halfway between the 10 and the 32. Everybody kind of agree with that? That's what it looks like. So that should be then the y-coordinate of the maximum plus the y-coordinate of the minimum divided by 2. So I have k is 21. Everybody good so far? Okay. The amplitude is like half of that distance, right? So if it's a distance, we're going to be subtracting the y-coordinate from the maximum and the y-coordinate from the minimum. Oops. It'll be 11. So we know that the a is plus or minus 11. So far, so good? The last thing I need to do now is figure out the sign for my a and the value for h. Well, I know for my parent function we chose to be cosine. So when we do cosine, we're using the 0.01, which is a max. From our resultant function, I need a extreme point. I could use 510 as a minimum or 1532 as a maximum. It doesn't really matter. Each one is doable. I'm going to choose to use the maximum. Since both of them are maxes, that tells me that the a value is positive. And because we've gone from 0 to 15, the h is going to be 15. We now have everything we need to put this together. So y equals a times cosine of 1 over c, but instead of c is 10 over pi, instead of writing 1 over 10 over pi, I'm just going to write the reciprocal of 10 over pi. And then x minus h plus k. Everybody's feels okay? Should feel very similar to what we've been doing, right? It's just a little bit more abstract because there's no picture to look at immediately. You have to kind of use a little bit of imagination on your own. Dominic. As an aside, like those guys might be good note card things to have, right? Those are kind of new formulas we just kind of came up with. Now, I think that most of them you can just get from looking at your picture, right? It's not too difficult. But if you want to put those into your note card, they are things you'll use relatively frequently. Katie?
Why did you divide for K and for the English? Why did you divide?
So well, K is like this line, right? That's halfway between 10 and 32, correct?
Oh, okay.
So that's why it's dividing by 2, because it's like halfway between them. And then the amplitude is like half the distance from the min to the max. Again, that's why I'm dividing by 2.
Okay.
Does that feel okay?
Yeah.
Okay. So that's it for section 3.1 today. We've done it. We finished it. What haven't we done yet? That we do every chapter. Homework quiz. What should you be expecting soon? Homework quiz. Should you be able to do the topics we've talked about from 3.1? Yes. When might be a good day to do that? That seems like a good day to me too. The rest of that day, I'll have a Delta Math assignment for you and have some problems from the book to work on when you're done with that, but that'll be basically our day. Wait.
What homework is due on Sunday?
So far it's worksheets 2 and 3. You have your meeting.
Yeah.
Have fun.
Thank you.
Who are you going to go see?
It's just Indiana.
Just Indiana. You have to say just. It is Indiana. It'd be cool to go there, right?
Thank you.
Maybe.
Yeah.
I don't know. We okay? All right. I'm done for today. You guys, while you have access to a mathematical wizard, should start on this assignment. So if you are confused on something or want to check any work or ask questions, you can do that much more easily now than you could, say, in 6 hours or 10 hours or 24 hours, until we meet again, right? So please take some time to do that now. Should be able to knock, I think, I had a student in 6th hour finish, I think, before the end. So if you're diligent and you feel good about what we're doing, that's a realistic goal. If you're still figuring things out, don't expect to finish. But you can make a lot of progress and should be able to feel a heck of a lot better by the end of class than you did at the start, after having some chance to practice some stuff, right? Okay. Everybody feel okay about the plan? Okie dokie, artichokes.